You think the speed of light is just a number. 299 million meters per second. A fact you memorized once, maybe for an exam, maybe just as trivia. Fast. Extremely fast. The fastest thing we know. And somewhere along the way, you were told something else. Nothing can go faster than this. Most people stop there. They treat it like a rule. A law written into the universe for no particular reason. Einstein said so. Physics says so. End of story. But that's not understanding. That's just repetition. When you actually ask why light speed is the limit, not how fast it is, not how we measure it, but what is truly stopping you, you don't find an engine problem, or a fuel problem, or even a technological problem. You find something far stranger. You discover that the universe itself is built in a way that makes faster than light not forbidden, but meaningless. Asking to go faster than light is like asking to go north of the North Pole. The question breaks before the answer does. To see why, we have to forget light for a moment. And we have to forget Einstein. Let's start with something that feels obvious. Things fall. Drop a stone, it falls straight down. That seems simple enough. Obvious. Almost boring. But centuries ago, that simple fact bothered someone enough to look closer. Galileo noticed that falling objects don't speed up randomly. They accelerate at a precise, predictable rate. 16 feet in the first second. A measurable pattern hidden inside something everyone thought they already understood. Now look up. The moon doesn't fall. It hangs there, night after night, circling the Earth without crashing into it. At least, that's what it looks like. But ask a sharper question. If the moon were suddenly frozen in place, no sideways motion at all, what would happen? It would fall. Straight toward the Earth, just like the stone. So why doesn't it? Because it's moving sideways. Fast enough that as gravity pulls it downward, the Earth curves away beneath it. The moon is falling all the time, it just keeps missing. That realization belonged to Newton. And it changed everything. Newton asked a dangerous question. What if the same force that pulls a stone to the ground is the force that holds the moon in orbit? That idea alone was radical. But Newton didn't stop there. He tested it. The moon is about 60 times farther from Earth's center than we are standing on the surface. If gravity weakens with distance, specifically with the square of the distance, then gravity at the moon should be 3,600 times weaker than it is here. Do the math, and something astonishing happens. The amount the moon falls toward Earth each second matches exactly what Newton's law predicts. This wasn't philosophy. This wasn't metaphor. It was a numerical match between two completely different phenomena. Suddenly, falling apples, orbiting moons, planetary motion, tides, all of it collapsed into one law. For the first time, the universe looked unified. And once you have a law that works, you can use it as a tool. That's where something unexpected enters the story. Astronomers noticed that the moons of Jupiter didn't behave exactly as Newton's equations predicted. Sometimes they appeared early. Sometimes late. By minutes. That should have been a disaster. But instead of throwing away Newton's law, a scientist named Ole Romer made a quieter, more daring move. What if the moons were doing exactly what Newton said, but the information about them was arriving late? What if light takes time to travel? When Jupiter was closer to Earth, the moons appeared on schedule. When Jupiter was farther away, they lagged behind. From that delay, Romer calculated something no one had ever measured before. The speed of light. Not by timing light directly, but by trusting one law enough to discover another. That detail matters, because it shows something crucial about how physics really works. We don't discover laws in isolation. Each good explanation becomes a lever that pries open deeper ones. Once the speed of light was measured, people assumed it behaved like every other speed. If you move toward a sound source, the sound reaches you faster. If you throw a ball from a moving train, the ball's speed adds to the train's speed. That's how velocities work. Or at least, that's how they work in everyday life. So imagine this. You stand still and shine a flashlight. You measure the speed of the light. 299 million meters per second. Now you get on a train moving at half that speed. You shine the flashlight forward, in the direction the train is moving. Common sense says the light should be faster now. Light speed plus train speed. But when you measure it, you get the same number. You try again. Faster train. Same result. Faster still. Same result. No matter how fast you move, light always moves away from you at exactly the same speed. This is not a measurement problem. It is not an illusion. It is not a limitation of instruments. This is the moment where reality stops behaving the way your intuition demands. Einstein didn't invent this result. He accepted it. And then he asked the only question that made sense. If the speed of light is the same for everyone, then something else must be giving way. It turns out, it's not light that adjusts. It's you. Time slows down. Not psychologically. Not metaphorically. Your clock actually ticks more slowly when you move fast. Distances shrink. Space itself contracts in the direction of motion. These changes are not side effects. They are not corrections. They are the mechanism. The universe reshapes time and space so that the speed of light comes out the same for everyone. This is the point where most explanations stop. But this is not the end of the story. Because now we can finally ask the real question. Why does this create a limit at all? As you push an object faster and faster, something strange happens. It resists acceleration more and more. Not because the engine weakens. Not because fuel runs out. The object's inertia increases. The closer you get to the speed of light, the more energy you need for each tiny increase in speed. Approach the limit, and the required energy grows without bound. To actually reach the speed of light, you would need infinite energy. Not a lot of energy. Infinite. And infinite energy is not something the universe can provide. This is not a rule imposed from outside. It is a consequence of how space-time is structured. Light doesn't travel at this speed because it's special. It travels at this speed because it has no mass. Anything without mass must move at this speed. Anything with mass cannot. The speed of light is not just the fastest thing. It is the conversion factor between space and time themselves. It is the rate at which cause and effect can propagate. And that realization leads somewhere even stranger. That light speed is the rate at which cause and effect travel, quietly changes everything. Because if information cannot move faster than light, then reality itself has a built-in order. Events don't just happen. They happen after something else makes them happen. Cause comes before effect. This sounds trivial, but it isn't. Imagine you could send a signal faster than light. Not a spaceship. Not matter. Just information. With the right setup, that signal could arrive before it was sent. Not metaphorically. Literally. From another observer's perspective, your effect would precede your cause. The universe would no longer agree on what happened first. And once different observers disagree on the order of events, the idea of before and after collapses. Paradoxes appear instantly. Messages from the future. Effects that erase their own causes. Logical loops with no consistent solution. Physics doesn't ban faster than light travel because it's inconvenient. It bans it because allowing it destroys the structure that makes events meaningful. This is why Einstein didn't treat light speed as a property of light. He treated it as a property of space-time itself. Space and time are not separate arenas where things happen. They are woven together into a single structure, space-time. And the speed of light is the slope of that structure. To understand this, imagine space-time as a fabric. Every object traces a path through it, not just through space, but through time as well. Even when you are sitting still, doing nothing, you are moving. You are moving through time at full speed. When you start moving through space, something has to give. You can't move fully through space and fully through time at the same time. So the faster you move through space, the slower you move through time. This is not a philosophical statement. It is measurable. Atomic clocks on fast airplanes tick more slowly than clocks on the ground. Satellites orbiting Earth experience time differently than we do. GPS systems must correct for this effect every single day, or they would drift kilometers off course. Relativity is not abstract. It runs quietly inside your phone. Now notice something subtle. Nothing in this picture says you can't keep accelerating forever. What it says is that no matter how much energy you pour in, you will never cross a certain boundary. As your speed increases, time for you slows down. From your perspective, you can travel vast distances in what feels like a short time. But to the outside universe, you never quite reach light speed. The limit is not experienced as a wall. It is experienced as an asymptote. You get closer, and closer, and closer, but never there. This is why asking what happens at light speed is the wrong question. Nothing with mass ever reaches that state. Light doesn't experience time the way we do. For a photon, the journey from emission to absorption happens without duration. But that doesn't mean light has a perspective like ours. It simply means our concepts stop applying. This is another pattern you see again and again in deep physics. At the edge of our understanding, familiar words lose their meaning. Speed stops being just speed. Time stops being universal. Space stops being absolute. And limits stop being barriers, they become definitions. The speed of light is not the fastest thing because the universe is cautious. It is the fastest thing because it defines what fast even means. It is the maximum rate at which the universe allows one event to influence another. Without that limit, the universe would not merely behave differently. It would be incoherent. Now here's the part that almost no popular explanation emphasizes enough. Einstein didn't arrive at this by experiment alone. He arrived at it by insisting on consistency. The laws of physics must look the same to all observers. That was his starting point. If Maxwell's equations say light moves at a fixed speed, then that must be true for everyone, not just for one privileged frame of reference. Instead of discarding the equations, Einstein discarded something else. Absolute time. That was the real sacrifice. Once you give up the idea that there is a single cosmic clock ticking the same for everyone, everything else falls into place. Time becomes local. Simultaneity becomes relative. The universe keeps its speed limit without contradiction. This is why relativity feels unsettling even today. It doesn't just tell you new facts. It tells you that some of your deepest assumptions were never true to begin with. There was never a universal now. There was never an absolute rest frame. There was never a background stage on which reality played out. There is only space-time, flexible, dynamic, responsive. And light speed is its signature. Later, Einstein would push this idea even further. If space-time can stretch and contract due to motion, what else can shape it? The answer was gravity. Mass and energy curve space-time. Objects follow the curves. Falling is just moving along the straightest possible path in a curved geometry. In that picture, light doesn't even feel gravity as a force. It simply follows space-time shape. And once again, light speed remains unchanged, not because it's stubborn, but because it is woven into the geometry itself. This is the deeper reason nothing outruns light. Not because engines are weak. Not because technology is primitive. But because faster-than-light motion would require space-time to contradict its own structure. The universe is not preventing you from breaking a rule. It is showing you what the rules are made of. And that's what Einstein really uncovered. Not a speed limit, but a framework. A framework where space and time are not passive containers. Where motion reshapes reality. Where limits emerge from consistency, not prohibition. Once you see it this way, the question changes. You no longer ask, why can't we go faster than light? You ask, what kind of universe needs this limit in order to exist at all? And that question doesn't collapse your mind. It quietly rearranges it. If this kind of deep, reality-level thinking interests you, tap like, subscribe, and stay here. Because the universe has many more limits that turn out not to be limits at all.